Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about section of solids. I am Dr. AIP Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided a triangular prism with base side of 50 millimeter and axis height is equal to 75 millimeter. And this triangular prism stands on its base onto the horizontal plane with one rectangular face lying perpendicular to the vertical plane. So here, if we choose this orientation of the triangular prism and this prism is lying onto its base on the horizontal plane, so into this orientation, none of the rectangular edges of this particular triangular prism will be perpendicular to the vertical plane. So this position of the triangular prism, it is incorrect. Whereas if the prism is resting onto its triangular base onto the horizontal plane into this orientation, then we will find that this rectangular face 1, 2, BA. So this face will be perpendicular to the vertical plane over here. So this way, this is the correct orientation of this triangular prism with respect to the two reference planes, horizontal plane and the vertical plane. Now we have been provided with the information that this prism is cut by an auxiliary inclined plane in such a way that the true shape of the section which is obtained after the sectioning of this triangular prism with the auxiliary inclined plane, so it happens to be isosceles triangle having base 42 millimeter and altitude of this isosceles triangle happens to be 36 millimeter high. Now let us first of all evaluate how does this auxiliary inclined plane cut this triangular prism such that we obtain the true shape of the cut section as an isosceles triangle having base 42 millimeter and altitude height 36 millimeter. So we can check. In this case, we have not been provided with the angle of inclination of the auxiliary inclined plane with respect to the horizontal plane. So once we know that it is an auxiliary inclined plane, so one thing is clear that this auxiliary inclined plane should be perpendicular to the vertical plane and it should be inclined to the horizontal plane. So since the angle of inclination has not been provided to us, rather the dimensions of the true shape have been provided to us over here. So in order to obtain the true shape of the cut section as an isosceles triangle, now the cutting plane must intersect this triangular prism at 3 points over here, right? That is the first thing we need to understand, because isosceles triangle will be having 3 corners over here. Next thing is, we know that the base of the isosceles triangle happens to be 42 millimeter. So now the cutting plane, that is the auxiliary inclined plane, should be cutting the top face of this triangular prism at 2 points, and these 2 points, they should be obtained on the adjacent edges over here. So these are 2 adjacent top face edges over here. So onto these 2 adjacent edges of this triangular prism on the top, so we should be obtaining 2 points of intersection of the cutting plane with the triangular prism over here. And where these 2 points should be located? So these 2 points should be symmetrically located about this axis over there. That is, once we draw this triangular prism, we'll locate the axis, and about this axis, now this axis will constitute the midpoint of the base of this isosceles triangle. So that if this dimension of the base happens to be 42 millimeter, so on the either side of axis, we are going to measure the distance of 21 millimeter on the either side. So wherever we are going to find 42 millimeter distance between these two points of intersection alongside these two adjacent edges which are lying on the top of this triangular prism. So this position of the location of the auxiliary inclined plane onto the top face will be identified. Now question arises where the third point will be located, because 2 points we have located symmetrically at distance of 21 millimeter on either side of the axis over here. So these 2 points we have located which will be apart by 42 millimeter in totality. Now the third point will be available on the vertical edge which will be passing through the intersection of these two edges onto which these 2 points of intersection will be lying. Why this condition we have to apply? Because if we obtain this third point onto this vertical edge, then the distance of this third point of intersection from first point of intersection and from the second point of intersection will be the same, because these 2 points, they have been located symmetrically about the axis of this particular triangular prism. So since these 2 points are symmetrical, therefore the distance of the third point of intersection from these 2 points will remain the same. And now question arises, how do we locate this point? So we have been provided with this information that the altitude of this triangle happens to be 36 millimeter. So from these 2 points, if we join these 2 points, so the shortest distance between these 2 points and the third point which will be available over here, so this altitude will be equal to 36 millimeter. So let us now proceed to evaluate the construction of the front view projections, the top view projections of the section triangular prism, and we will be evaluating the true shape of the cut section in such a way that we have to validate that this true shape of the cut section which has been obtained by cutting off this triangular prism by an AIP should be equal to isosceles triangle having base 42 millimeter and the altitude of this isosceles triangle happens to be 36 millimeter. So now we have to start with construction of top view projections below the XY reference line onto the horizontal plane. So we know that one of the edges of this triangular prism, it is perpendicular to the vertical plane. So we know the edge length, it is equal to 50 millimeter. So now into this orientation we have drawn an equilateral triangular prism over here having edge length is equal to 50 millimeter. So here we have got edge length of the prism equal to 50 millimeter. One edge of this prism happens to be perpendicular to the vertical plane. So as the observer is going to look at this triangular prism from the top, so we will be obtaining triangular projections onto the horizontal plane over here. So since 1, 2 and 3 points, they correspond to the base of this triangular prism. So we have marked these points on the inner side of these triangular projections. Similarly, corresponding to the top face, we have got 3 points A, B and C of this triangular prism. When we look at this prism from the top, so points A and 1, they will be coinciding with each other. B and 2, they will be coinciding with each other. C and 3, they will be coinciding with each other. So A, B and C points we have marked on the outer side of this triangular top view projections corresponding to this triangular prism. Now let us evaluate the axis point of this triangular prism. So in order to evaluate axis point of this triangular prism, we need to draw perpendicular bisectors from each of the 3 corners onto the opposite edges of this triangular prism. So from point 3, if we draw perpendicular bisector of the base edge 1, 2, so first perpendicular bisector projector we have obtained. Similarly, from the point 2, we have obtained the perpendicular bisector of the edge 1, 3. Similarly, from the point 1, we have obtained the perpendicular bisector of the edge 2, 3 over here. So this is the axis point corresponding to this triangular prism. That is, points O and O1 have been appropriately obtained. So where O point will be lying at the top face and O1 point will be lying at the bottom face of this triangular prism. We know that height of the prism, it stands 75 millimeter tall. So we have marked this height of the prism as 75 millimeter. So once we mark the height of the prism, now we can obtain the front view projections corresponding to this prism. So we can check points 2 and 1. They will be coinciding with each other onto the horizontal plane or onto the XY reference line. Why? Because 2, 1 edge happen to be perpendicular to the vertical plane. So points 2 dash, 1 dash, they have been obtained onto the XY reference line. Point 3, it will be projected as point 3 dash onto the XY reference line. Similarly, corresponding to the top face, points B and A, again they will be coinciding with each other. So points B and A, they will be projected as B dash and A dash, corresponding to the top face of this triangular prism. And the point C of the top face will be projected as point C dash at a height of 75 millimeter. Now we can locate the axis points O dash and O1 dash over here in the front view projection. So as we have already discussed, O dash is the axis point lying on the top face of this triangular prism, while O1 dash happens to be the axis point which lies onto the base of this triangular prism. Now we have been provided with the information that this triangular prism has been cut by an auxiliary inclined plane in such a way that the true shape of the section, it is an isosceles triangle having edge is equal to 42 millimeter. Now we can check the maximum edge length, it can be 50 millimeter. So if the maximum edge length of the isosceles triangle is required, then the cutting plane should have cut the solid at this particular position. Now we have got the true shape of the isosceles triangle as having the base 42 millimeter. So this is the axis line you can check. So around this axis line, now we have to locate, that is symmetrically we have to locate 2 points of intersection over here around the axis in such a way that this distance should be 21 millimeter and this distance should be 21 millimeter. That is, we have to locate this distance of the base equal to 42 millimeter in such a way that from the center of symmetry of this triangular prism, we have to locate a distance of 21 millimeter on this side and on this side. So what we are going to obtain through this, we are going to obtain 2 points of intersection over here. We can check. These are 2 points of intersection which are available with us by virtue of intersection of 2 adjacent edges of the top face of this triangular prism by the cutting plane. So point P happens to lie alongside the edge AC. We can check. Alongside this edge, we have marked this point as point P, and another point Q has been marked alongside the adjacent edge of the top face BC over here. That is 2 points alongside 2 adjacent edges we have located in such a way that the distance between these 2 points should be equal to 42 millimeter. From the front view projections, both of these 2 points, they will be overlapping with each other. So in the front view, this point will correspond to the 2 points of intersection P dash and Q dash of the 2 adjacent edges which have been cut by this auxiliary inclined plane over here. So this way, in the front view, one point through which auxiliary inclined plane should be passing, we have been able to evaluate. So here starting point was from the plan projection view. Now the second information available with us, it is that the altitude of this triangle, which will be the true shape of the cut section as it is being cut by an auxiliary inclined plane. So this altitude should be 36 millimeter. So now since we have to obtain the isosceles triangle, so the 3 points of intersection should be obtained while this AIP is going to cut this particular triangular prism. So the 2 points we have already obtained alongside the adjacent faces over here. Now the third point we have to locate alongside the vertical edge, which will be obtained by intersection of these two adjacent top face edges, which have already been cut by this auxiliary inclined plane. So the 2 points P and Q we have already identified. Now we are going to locate one point onto this vertical edge in the front view projection, that is the edge C-3' over here. So this is the edge 3' C'. Now we have to use this information that the perpendicular distance from the third point of intersection onto the edge, which is going to join the first 2 points, it should be equal to 36 millimeter. That is using the points P' and Q' in the front view projections. Now we have to keep our needle point of the compass at this position, and open compass is equal to the radius 36 millimeter. So once we open compass is equal to radius 36 millimeter, wherever the arc having radius 36 millimeter drawn through the points P' and Q' in the front view elevation projection viewpoints, it intersects with this vertical edge, generating through the intersection of these two top face edges onto which earlier 2 points they had been located. So now from this needle point of the compass we have drawn an arc having radius is equal to 36 millimeter. So the third point of intersection, so this was P', Q'. So this point we are going to label as R' over here. Now the moment we join the points P', Q' with R', we'll find that this distance happens to be 36 millimeter. And the third point of intersection, it has been obtained in the front view projections over here. Now having identified the point R' through which the auxiliary inclined plane should be passing, now we can check one point of intersection we had obtained over here. The second point we have also obtained. So in order to draw this auxiliary inclined plane, now these 2 points we are going to use over here. So obviously it is not single point. Here 2 points they have already overlapped. So once we join P', Q' and R', so we will be able to locate the orientation or inclination of this auxiliary inclined plane with respect to the horizontal plane. So if we draw a horizontal projector line over here, so this angle of inclination 18 degree or 20 degree or 15 degree, so that we can work out. So now the orientation of this auxiliary inclined plane has been evaluated. Now we work out that this point R' or R point, it is located somewhere here. So now if we are going to look at this vertical edge from the top, so we will find out that points C, 3 and R over here, so they are going to coincide with each other in the top view projection. So point R in the top view will be coinciding with points 3 and C, because all these 3 points they lie onto the vertical edge which is perpendicular to the horizontal plane. So now in the front view 3 points of intersection we have been able to locate. In the top view also 3 points of intersection we have located. Now we observe that this portion of the solid, it has been removed by the cutting plane or the auxiliary inclined plane. Now we are left with the remainder solid as this portion over here, which we have already darkened, right? Next, we also know that this is the triangular portion corresponding to this triangular prism which is available with us. And out of this total triangular portion, if we draw the vertical projectors through P' and Q', 2 points of intersection we have located over here in the top view projection. So if we join this portion, so this is our section portion, you can see P', Q' and R', it is the section portion corresponding to this triangular prism which is visible to the observer from the front view projections over here. Now since this AIP happens to be inclined with respect to the horizontal plane, so the projections of the sectioned portion, that is P dash, Q dash and R dash, which will be obtained in the top view projections, they will not be representing the true shape projections of this particular cut solid over here. So we are going to get the top view projections corresponding to the section solid as P, Q and R, and we have carried out the shading of this portion because it is the cut section. And now into the sectional top view, that is PQR, we have obtained the apparent shape projections of this cut section into the top view projections over here. So now in the front view, we have got the edge view projections corresponding to this AIP. In the top view, we have got an apparent shape projections corresponding to the sectioned surface. Now we are required to obtain the true shape projections of this particular sectioned cut surface. So how that can be done? So this is our auxiliary inclined plane whose orientation we have obtained in this particular case using the information that the true shape should be isosceles triangle having base 42 millimeter and altitude should be equal to 36 millimeter. Now we have to obtain this isosceles triangle over here into the true shape projections. So now corresponding to this AIP whose orientation has been obtained, we have drawn auxiliary inclined plane X1, Y1 which is parallel to this AIP or the cutting plane over here. Now there are 3 points of intersection P dash, Q dash and R dash which are available with us corresponding to the sectioned surface of the solid. So now from these 3 points P dash, Q dash and R dash, we are going to draw the perpendicular projectors onto this auxiliary inclined plane X1, Y1. And now the auxiliary plan projection view which we are going to obtain onto the auxiliary inclined plane X1, Y1. So it will provide us with the true shape projections of this cut section over here. Now here we have got one projector drawn through the points P dash, Q dash. This is the second projector drawn through the point R dash over here. Now onto AIP, the projections which are obtained, they are called auxiliary plan projection. So we have to plot the distances of these 3 points of intersection P, Q and R from the plan projection view. So now we can check. This is the distance of the point P from the XY reference line in the plan projection view. So we'll measure this distance of point P from the XY reference line. Now the same distance will be plotted ahead of the auxiliary inclined plane X1, Y1 corresponding to the projector line which has been drawn through the point P dash over here. So this is the projector line drawn through the point P dash onto this projector line ahead of the plane. So the same distance of the point P from the XY reference line will be plotted as the distance between X1, Y1 AIP and the point P1 over here. So the first point of the auxiliary plan projection view has been obtained. Now the second point we have got is point Q. So now we are going to measure distance of point Q from the XY reference line. This is the distance of point Q from the XY reference line. Now onto the perpendicular projector drawn through the point Q dash, same distance ahead of the plane X1, Y1 AIP. We are going to draw onto this projector line emerging from the point Q dash over here. So distance of P1 has been marked. Distance of Q1 has been marked in the auxiliary plan projection view. And the last point available over here is point R. Now we will be measuring the distance of this point R over here. So this point R we have got at this distance from the XY reference line. So once we measure this distance of point R from the XY reference plane, now corresponding to the point R dash onto this projector line. So same distance ahead of the plane X1, Y1 AIP we have marked it out over here as point R1. So now P1 point, Q1 point, R1 point. So all the 3 points, they have been appropriately located on the auxiliary plan projection view. So now if we join all these 3 points, so the true shape of this sectioned surface of the solid has been obtained, because this cutting plane happens to be parallel to this auxiliary inclined plane x1, y1. So since this cut section is parallel to this AIP, so the projections of this cut section obtained on this AIP will reveal the true shape projections corresponding to the sectioned surface PQR over here. So now we can verify that the distance between P1 and Q1 will be 42 millimeter, because it is this distance 42 millimeter which we have already plotted over here. So we can verify this distance will be equal to 42 millimeter, and if we draw a perpendicular projector from point R1 onto this edge P1 Q1 over here, this distance will be equal to 36 millimeter. How we can say this distance is 36? Because we can check, we have marked this length of the cutting plane over here from P dash Q dash to R dash as 36 millimeter. So if the length of the cut surface alongside the elevation projection edge view over here, if this is 36 millimeter, we have drawn a plane x1, y1 AIP parallel to this length over here. So onto this plane, so again R1 and this point over here, this distance will be again 36 millimeter. And third thing we can verify, we have discussed that this will be an isosceles triangle. So now we can measure the distance between P1 R1, we can measure the distance between R1 Q1. So we'll find that the distance of P1 and R1 and the distance between the points R1 and Q1, it will be equal over here. So this becomes an isosceles triangle having base is equal to 42 millimeter and altitude it is equal to 36 millimeter over here. So this way we have been able to verify that the true shape of the cut section which has been cut by this auxiliary inclined plane, it meets the condition that it is having the base 42 millimeter and altitude height 36 millimeter, and since P1 R1 and R1 Q1 distances, they are equal, so this is an isosceles triangle which we have been able to obtain. So this is all for today. So I hope that through this discussion you would have understood about how do we obtain the sectional front view projections, the sectional top view projections, and the true shape of the cut section using the auxiliary plane method over here. So I hope that through this discussion you would have understood about the procedure to evaluate sectional front view, top view, and true shape of the cut section of the solid. So we'll be continuing with further discussion regarding few more illustrative cases of section of the solids in the coming lectures. So thank you very much. Thanks a lot.